This video is about rational formulas and inversely proportional relations. We call two values inversely proportional to each other if, let's say, the two values are x and y. These two values are inversely proportional if, when I multiply x with a certain number a to obtain the new x, then in order to calculate the new y, I have to divide by that same number a. Let's look at an example. Say one person takes 2 weeks or 14 days to paint a house. The question is, how long does it take 3 people? We can assume that the relation between the number of people and the number of days it takes to paint a house is inversely proportional. Let's call the number of people x, and the number of days we call y. Then if one person takes 14 days, it takes 3 people, which is 3 times as much as 1, only 1/3 of the time as one person. So 14 divided by 3, or 4 2/3. This is what inversely proportional means, and is often used in situations where multiple people do the same work and therefore the amount of time it takes to do the work decreases. Note that if two values are inversely proportional, then the product of these two values is always constant. Let's look at our example. 1 times 14 is equal to 14. So if x is 1 and y is 14, then the product of x and y is 14. If x is 3 and y is 14 divided by 3, then the product is also 14. If I have some x times some value for y, then x is 1 times x, and y is, well, if x is x times as much as 1, then y should be 14 divided by x. Or 14x divided by x, or just 14. So no matter which values for x and y I take in this situation, because they're inversely proportional, the product of x and y is always 14. And because of this, we can also write the relationship between x and y down as a formula. Because now if I divide both sides with x, I have y on this side and 14 divided by x on the other. Using this, we can write any inversely proportional relationship into a formula. Let's say it's given that for some a is 4, we have that b is equal to 9. And it is also given that these two values are inversely proportional. Seeing as that a and b are inversely proportional, we know that a times b is constant and should therefore be the same as 4 times 9, and that is 36. In other words, any a times its corresponding b should result in 36. So that also means that b is that number 36 divided by a. Now let's look at our formula which we found earlier. Y is 14 divided by x. We call this type of formula rational. Any formula with an x in the denominator is rational. And any formula we can make a graph of. And in order to do that, the first thing we do is draw a table. So x and y, we know that 1 and 14 is on the graph. And 2 and 7 is on the graph. We also know that, and I have to make some room over here, that for a half, the corresponding y is 28. And for a quarter, the corresponding y is 56. If I divide x by 2, then I can multiply y by 2. Because dividing by 2 is the same as multiplying with a half. And if I multiply x with a half, I have to divide y by a half. And that is the same as multiplying by 2. So, to complete the table, given this table, we can draw a graph of it, and for that you have to draw a set of axes, find every single point, and draw the graph. I'm going to use GeoGebra for this graph, so it'll come out as neatly as possible. Our formula was y is equal to 14 divided by x. And as we can see, this does match our table. Because on the table was, for example, for x is 1, y should be 14. And that is indeed the case. And for 2, y should be 7, which we can indeed see. 2, 7. We can also see that for a half, the value is 28, just as we've seen in the table. So any rational function kind of looks like this. If we were to zoom out and allow negative axis, which is a bit weird because the formula is about people and number of days it takes to paint a house, so technically it cannot be negative, but let's see what would happen if we did allow for negative values. Then we would see the graph is symmetrical, and the same shape you see in this part, you see in this part. So that's basically what a rational function looks like.